So hey guys, how are you? I hope you guys are doing extremely well. So a quick disclaimer, a quick reminder that I'm not recording this video for teaching, but it is solely meant for the self-improvement purpose. But however, you can watch the video and can see how I approach the question. So you may get some idea of how to like approach a question, how to start solving a question. So without wasting any time, let's jump into the question. So the question is right in front of us. So we have got the question rotate list. Although I have solved it, but I have solved it in the first year only. So I don't remember the exact algorithm I use. But if I'm solving right now, what I will do, how I will approach. So the question is that given the head of a linked list, rotate the list to the right by k places. है ना? So we will be given a head of the linked list and we have to rotate the list by k places. है ना? So we have given the question. So let's jump into the iPad screen. So the linked list is what is this? So it's 1, 2, 3, 4, and 5. So this is the and k equals to 2. So we have to rotate this list by k equals to 2 means 2 places by right. So while rotating with k equals to 1, this 5 will become the head now. So 5 will become the head and rest of the linked list will remain same. Now 4 will point to null. Then k equals to 2, which is our final answer. So 4 will become the head now. 4, then 5, then 1, 2, 3, and this is the final linked list, right? So the first approach which can come into my mind is that first of all, I can store them in the vector and then rotate that vector by k places to the right and then construct the linked list. So yeah, so let's do that first. So here we go. So let's have this vector. So I will first come to this and insert 1, then 2, and then 3, and 4, then 5, and then 8. So what I will do is I will use a while loop, and what I will do while current is not equals to null, I will do the iteration, and then after that I will make a no, other I will again I will loop. Sorry, the first step will be to step 1. This is step 1, right? Step 1 will be linked list to integer, linked list to array conversion. Then step 2 will be rotation, right? Array rotation. So I will rotate the array. So for rotation by k places to the right, I will use a algorithm which we used in reverse the array 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Right. So what? Array rotation. What I will do, first of all, I will reverse this. Step 1 will be reverse array. So step 1 will be reverse the array. So array reversal will make it 5, 4, 3, 2, 1. And I will make sure that my k will be k modulus 10, because k may be larger than the size of the array. So we can use this so that we don't have to, like, for example, if I let me make it clear. If I suppose take this array as an example, 1, 2, 3, 4, 5, है ना? So let me copy it. Okay, just a second. Three, 4, 5. So k equals to 0, k equals to 1, k equals to 2, k equals to 3, and k equals to 4. My mistake, k will start from 1. No, 1, 2, 3, 4, 5. So when I'm rotating the array, when I will rotate the array by 1, this 5 will come into the this 0th index, 5, then 1, 2, 3, 4. And when k equals to 2, this will come into the first index, and rest 1, 2, 3. And when I will rotate it by 3 places, so 3, 4, 5, 1, 2. When I rotate it with 4 places, it's 2, 3, 4, 5, 1. When I rotate it with 5 places, 1, 2, 3, 4, 5. Now, so when I'm rotating it with the 5 places, you know, the size is also 5 and the k is also 5. So after k, sorry, n modulo k, for every first 5 k, the array will become the same. So if suppose we have n is equal to 10 and k is equal to 20, so we know that there will be no change, and there will be no changes in the array, because n modulo k equals to 0, and for k equals to 0 there will be no change. So we can use this concept there. So what we were doing, array rotation, right? We take it to downside, array rotation. So we will do this, huh? So the first step will be reverse the array, then k equal to k modulo something. So something will come here. For example, here k will be equals to 2. So we have to reverse the array. We have to reverse the array, leaving the first two indices. So first two indices will be this, and we have to reverse this remaining part, right? So 5 will be there, 4 will be there, 1, 2, 3. So our array is reversed. Yeah. So what we have to do for rotating any array? First, we have to rotate the whole array, and then we have to rotate the. We have to leave the first k indexes, and then the remaining array should be reversed. This is for the right rotation. है ना? So coming back to our original question. So when the array is reversed, now we have to just convert this into the linked list. है ना? So we will do this in coding part. So let's go into the coding part. So let's go. So first of all, what I will do, I will make a vector of int arr, है ना? And then we will take our list node temporary head, है ना? Temporary head that will be equals to head itself. So what I will do, while temp head not equals to null, है ना? While temp head not equals to null, arr dot push back temp head, and let's see how the data is defined. Int x next temp next value, है ना? va, and then we have to update this. Temp head is equal to temp head next. So here what we did, convert list into vector, and converting the list into the vector. So now rotating the array by k places right. Now, so first of all, we need to get the value of k. So k will be equals to arr dot size modulo k. Now rotating the array by the k basis. First of all, reverse करना पड़ेगा. We have to reverse it ना. So let me comment it. Step 1, reverse the array, है ना? So reverse arr dot begin, comma arr dot end. Step 2, final step है ना? So what was the final step? We needed to reverse the leaving the first k index. So RSE plus 2. So arr dot begin plus 2 comma arr dot end. So our array is also ready. Now I have to construct a what? Now I have to construct the linked list from the array. So I have to store the head somewhere. So let's use that temp head variable. Temp head equals to I can do new list node ARR of 0. I hope we use like this only. Yeah. So for int I is equal to 1, I less than ARR dot size I plus plus. So here, so let me discuss the algorithm behind the construction of list from the array, like how we will construct a list from the array. So since we have got the array here, 5, 4, 3, 0, 1, 2, 3. So what we will get, first of all, we will initialize a new node, है ना? And new node with the value 5. So we have initialized the new node with the value 5, and we have taken its next equals to null. Then we will iterate from the first index, leaving this index, because we have already initialized the new uh, head here with new node. So now what we will do, we will iterate this index, we will add, we will keep a temporary variable, and we will keep track of the tail, because we will at the end we will add to tail only. So like, so tail will be temp head, at first the tail will be the first node itself, so temp head will be there. That is, let's take it tail equals to 5. So we will iterate it, and we will attach the tails next to this new node. So 5 is there. So 5's next we will add the new node, and new node next will be null, and the tail will be updated to 4. Now similarly we will iterate to 4. Just a second. Okay, so 4, after after moving to the 1, so it will be same. This 1 will be there, and one's next will be null, and tail will be updated to null. Then next element, so next element will be 4, 1, this will be 2, and two's next will be null, and and it tail will be updated to 2. Now 5, 4, 1, 2, and then the new element is 3. 3's next will be null, and the tail will be updated to 3, but the array is exhausted, and we have stored the head into the temp head, so we will return the temp head. So this is the actual working. So let's complete this. So list nodes star tail equals to, so I forgot to use star here, so it will be temp head. So temp head next equals to a list node star temporary node is equal to new list node ARR of I, then tail tail next is equal to temp node and tail is equal to temp node. Then we have to return the uh, temp head. I hope it's working. Let's check. First we have declared the vector, then the temporary head. While temp head not equals to null, arrow.pushback temp head value. Then next, then rotating the array by k places, right? So k, we got the value of the k, then reverse it, then while 2, it should be k. Then error of 0, temp head new, temp head is equal to new list node, error of 0, okay, conditional temp head, okay. Then this temp node, tail match is equal to temp node, tail is equal to temp node, return temp head. Hope it's working fine. What is this error? Okay, this spelling mistake. Mhm. Okay, we are getting the wrong answer. What? K is equal to 4. So ideally it should and now K is equal to 1. What where it went wrong? K is equal to error dot size modulo K. We have updated this K. Okay, out. I got the mistake. Hmm. There is one thing. There is one thing. Like 1, 2, 3, 4, 5. So if I am rotating this with uh, k equals to 2, so what I did was, first of all, I reversed the entire array. Then I told leave the first k indexes and reverse the other part. So that was the mistake. We have to reverse that part as well. So one thing, reverse error dot begin, comma error dot begin plus k. I hope now it's fine. Otherwise, it will be the range issue, inclusive, exclusive. Something is wrong here. Okay, just a second. Add is, yeah, I forgot to use that window. Oh yeah, I got the mistake. That will be K modulo ARR size. K modulo ARR dot size. This was the mistake, I guess. Yeah. Uh, Division by zero. Is it the case? Okay. So what I did was that the blender was I did two mistake. First, I had to divide with k modulo size, but I did size modulo k. So that was the first mistake. And the most important edge case which I missed is that the missing that edge case that if the linked list is empty, like head is null, enough. So that I needed to take into account. So for this approach, what will be the space complexity? Space complexity is order of n, and time complexity will be order of n for list traversal plus order of for the construction. And one thing I missed, order of log n for the reversing the array. है ना? So overall space complexity will be order of n and time complexity will be order of n log n in asymptotic terms, right? This is the first and the very brute force approach which I can think of. Then on further moving to some optimized, like what we can reduce. We can reduce the space complexity. Yeah, we can. How? Let's discuss. So let's take the list first. 5. So what we I can do is that step 1, what I can do, get the number of elements in the list, like the number of nodes in the list. So the number of nodes will be 1, 2, 3, 4, 5, right? 5. So number of nodes is equal to 5. Get the value of k. Step 2 will be get value of k. So k is equal to k modulo 5, that is 2 modulo 5. So k will be 2. Now what I will do is I will traverse this. I will traverse this, है ना? Uh, I will traverse this, and I will leave only k elements from the last. So how I will leave the k element from the last? Uh, Size minus k, that will be equals to 3. So I will travel 3 nodes, 1, 2, 3, and I will get the temporary node, है ना? What I need to do, I need to get a 4. What I will do, I will chop this part, so this part will become 1, 2, 3, है ना? And I will take this part and attach it to 4, then 5, then it will become reversed. So what I need to do is I need to get this I need to get where I have to chop off, and then I need to get the address of the tail as well. I need to get the tail as well. So what need so this is quite simple. So we need to code it. I don't think we need to dry run this part. Okay, let's dry run this part. 1, 2, 3, 4, and the 5. So the algorithm what I will use is uh, when the steps will be equals to n minus k, what I will get? I will get the head. Head is equal to at this position. Then I need to traverse till the last to get the tail. Because I need to attach the tail to the original head of the current list. So this is the head. I will traverse this, and steps will be equals to 1. Then I will move, and step will be equals to 2. Then I will move, step will be equals to 3, है ना? At 3, so अपना new head will be 3 is next, so 4, right? Then I will move to here, it will be 4. Then I will move here, it will be 5. And for the getting the tail, what I will do is I will iterate until the uh, current nodes next is not null, है ना? So if I am here, I am seeing this 4's next is 5, so it means it's not the end of the list. Then I will I will be here. Then I will check if the current nodes next is null. If it's null, then then I am sure that this is the last tail. So we will get the tail as well. No. So tail as well will be there. Then tail will be 5. Now one thing I forgot is that when I will reach to k equals to n minus k, sorry, steps, then what I will do at the first I will get the head, and then I will make this next to null, and I will disconnect this part. So apparently what I have 1, 2, 3, this thing. Then I have new head as 4, so new head will be 4, and the tail is 5. So 5's next will be connected to current head, and this will become the new head. I hope I'm able to persuade what I mean to say. So go uh, let's go and code this part. So if not head, then return head. So if the linked list is empty, then I have to return that empty head. That head will be equals to null. Now int n is equal to 0. What I will do is while let me get a list node star temp is equal to head, because I don't need to tamper the original head. I have to always take a copy and work on that head only. So while temp not equals to null, enough, what I will do n plus plus and temp is equal to temp next. So here I will get the number of nodes. Then I need to get the proper value of k. K is equal to k modulo n. I got the thing now. While temp next not equals to null, right? And I have to count the steps as well. So in steps equals to 0, 0, 1, 2. Let's make it 1. uh, Here it was, first of all it was 0, then became 1, became 2, then became 3. So yeah, it will be the steps will be 0. First step which I will do is steps plus plus. Steps plus plus. Then if steps equals to n minus k, sorry, n minus k, then I need to get one new node as well. Next node star new head equals to null. I have initialized the new head and the tail as well. And one thing I need to reassure is temp is equal to head, because the head will be changed. So temp need to be reassigned with the value of the head. So steps is plus plus, and is if steps is equal to n minus k, then what I will do is simply new head will be equals to temp, right? Now I need to update the temp is equal to temp next. Temp will be equals to temp next. Did I need to do something else? Yeah, I needed to break that link as well, Anna. So now I will break. One thing I need to do here, I need to break the link. How I will do that, I need to figure it out. Steps will be plus plus, and if steps is equal to n minus k, the new head will be temp next, right? So I can make it temp next is equal to null. Yeah, and temp next will be new head. Shit. This will be done here only. Temp next is equal to null pdr, and temp next will be null pdr, and temp is equal to new head, and I need to continue. So this will be temp, temp is equal to temp next. Two times. That link is also broken, and I have got the new head as well, and I need to get the tail, and tail will be there. So what I need to tail next is equal to tail next is equal to current head. I need to return new head. I hope I did not miss anything. So I think it will not be tail, it will be temp, and I need not to have the tail. And I will be having the one unused variable. Yeah. So there is no need of the temp variable. It's tail. It's fine. So that is the simple part that's submitted. Got the wrong answer. If k equals to 0 or k equals to 0, again I missed the important test case. I think 0. So one thing here to learn is that we always have to take care of the set. So one thing I just forgot. If k equals to 0, then I need not to do anything. So I just have to return the head only, right? This is the ultimate solution, I think. It will cover all the cases now. Yeah. So here, just a small uh, like advice to me as well and to you. You are seeing that you always have to account for the edge cases. So let's get the time complexity and space complexity. So here the simple thing was that the space the space complexity is order of one constant, है ना? We didn't use any space, and the time complexity is order of n, right? Order of n plus order of n, है ना? Order of n was to get the number of nodes, and order of n for final traversal. We can say the final traversal or getting the links. So this is it. We will meet tomorrow with the new question.